Welcome to the test solving session on the topic Theory of Structures. Atelier Lab is an academic finishing school as an initiative by alumni from prominent Indian institutions, including NIT, IIT, and SPA. We deliver structured online courses on competitive exam preparation and career advancement skills for architects and planners to achieve excellence in their career. The programs are led by experts who focus on building conceptual clarity and test readiness. Join us for GATE Architecture and Planning 2026 Support Program by Atelier Lab. The new batch starts from 1st December 2025. You get access to 40 recorded classes covering the entire GATE architecture syllabus. 40 topic-wise practice tests, unlimited access to study materials till the exam, online doubt clearing sessions every week, mock test series with detailed solutions. All this at the convenience of your home. WhatsApp us for enquiries on +91 808 99 39570. Thank you.
Problem 2. A simply supported RCC beam of span 4 meter is supporting a brick wall over its entire span. The brick wall is 250 mm thick and 2 meter high. RCC beam has a depth of 600 mm and a width of 250 mm. The density of brick masonry and RCC can be assumed as 18 kN meter cube and 25 kN meter cube respectively. Considering the load of the wall and self-weight of the RCC beam, we have to find the maximum bending moment in beam. So, given, we know the span. Span of the beam and the brick wall is 4 meter. First one, brick wall. Brick wall thickness is given as 250 mm and height is 2 meter. So first we have to you can see it here, thickness. First we have to convert this 250 mm into meter. So always remember, always use a single unit. If it is mm, you keep it as mm for all the different parameters. Otherwise, convert. It's always better to convert all the parameters into a single unit at the initial stage itself. Okay, so thickness is 0.25 meter, height is 2 meter, which is given, and density of the brick wall is 18 kilonewton per meter cube. Okay, so next is RCC beam. RCC beam depth is 600 mm and width is 250 mm. So we have to convert it into meter. So width is 0.25 meter and depth is 0.6 meter. Density is given as 25 kilonewton per meter cube. So these are the given parameters. So first thing is we have to so the formula which is already given in one of the slide, you can check that. Formula for finding the maximum bending moment for a simply supported beam with UDL. In the figure, you can see this is a simply supported beam. And there are 3 different conditions we have studied. Either it can be a point load, or it can be a UDL, or it can be uniformly varying load. So looking at the figure, it's not a point load. So it is covering the entire span throughout with the same load, which means that it is not a uniformly varying load also. So this is a UDL. So simply supported beam with a UDL, the maximum bending moment is given by the formula WL square by 8. So we know the formula. So in that we have to find W. W is the total load. L is given as 4 meters. So L we know. So only thing we have to find is W. To find the total load acting on the beam, we have to see that step by step. First step is we have to find the brick wall load per meter length. So we'll find the brick wall load and then we'll find the RCC beam load. Okay. So first we'll find volume per meter. So for 1 meter, we have to find the volume. Volume is B into D into H, breadth into depth into height. Okay. So breadth is given thickness 0.25 into height is 2 meter. Okay, the length we'll take as 1 meter because we are taking it for volume per meter. So 0.25 into 2 into 1, which is 0.5 meter cube. And they have given the density. So if density is given and volume is given, then we can find the weight. Density equals, I'll write the formula here. Density equals weight by volume. Okay, so you can find the weight here. Weight of the, one second. So you can find the weight of the brick wall. Weight of the brick wall equal to density into volume. Volume we have already found out, which is 0.5 meter cube. Density is given in the question, that is 18 kilonewton per meter cube. So we can find the weight of the brick wall as 9 kilonewton per meter. In the next step, we will find the self weight of RCC beam per meter. So same procedure, volume per meter, 0.25 into 0.6 into 1. Length is taken as 1 meter, that is 0.15 meter cube. Then weight of the beam, again density into volume, that is 0.15 into 25, which gives you 3.75 kilonewton per meter. Next, we'll take total uniform load by adding the brick wall load and RCC beam load. We'll get 12.75 kilonewton per meter. So substituting the total load in this formula, we'll get 25.5 kilonewton meter as a maximum bending moment.